Okay, relation. Any set of ordered pairs is a relation. The set of all first components and the ordered pair of a relation is the domain of the relationship, and the set of all second components in the ordered pairs is the range of the relation. This just goes back to ordered pairs, right? Remember the ordered pairs were x and y, and we know that domain, right? Domain has to do with x's, and we know that the range has to do with the y, right? So that's all they're saying there about the pair, right? Right. So they're saying has to do with the first component is the domain. The second component is going to give you the range. It's going to give you that. Okay. So a function is a set of ordered pairs in which each distinct first component corresponds to exactly one second component. Okay. So what that means is if we plug in the first component, we always get the same second component. I plug a 0 into this function, it spits out a 1. Plug in a 2, it spits out a 5. I plug in a 3, it spits out an 8. I plug in a 4, it spits out a 2. Every time I plugged in a different x value, a different input, it spit out one and only one output. So this is a function. All right, so this is still a function over here. This is my typo. So this right here is actually still a function as written. So, all right. So this right here is a graph representing this concept. So 0 goes to 1. All right, so 0 goes to 1. You can just follow it. And this basically shows what I meant by every one of the values in the domain goes to one and only one values within the range. Okay? And because of that, we would say this is a function. Now, we could set up a different set that would give us different information. Now, as a function, we could look at the domain here. The domain are all the possible x values, right? So the domain would include a 0, a 2, a 3, and a 4. The range are going to include all the y values, so we're going to include a 1, a 5, an 8, and a 2. And this is a function. Yes, this is a function. Okay, now the second one, this is not represented by this graph here, but when I plug in a 3, I get a 5, but when I plug in a 3, I also get a 6. When I plug in a 3, I got a 7, and when I plug in a 3, I got an 8. That is definitely not a function, because for every input, I don't just have 1, right? And I have 3. So if I wrote my own graph here, right? So if I wrote a graph, I would have 3, and then the other one, I would have a 5, I would have a 6, I would have a 7, and I would have an 8. And that is the problem. As you can see, if I kind of graph it, notice that that 3 doesn't just go to 1, right? It goes to 4 different numbers, right? So when I put in that 3 as an input, it spits out 4 different possibilities. So this is super not a function, right? Okay, now the domain is simply going to be 3. Again, all possible x values. The range is going to be 5, 6, 7, 8. And is this a function? No, it's definitely not a function, right?